Fellow citizens, good afternoon. Ethan here, and we will now learn about the Fibonacci sequence. So it is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. It goes on and on in an infinite manner, meaning it never ends. And the Fibonacci sequence is a series where each number is the sum of the preceding numbers. It is noted by Italian mathematician Leonardo Pisano. He introduced it in the context of the problem of how many rabbits, how many pairs of rabbits are there in an enclosed area. End of quote. Here now is the formula for the Fibonacci sequence. It is defined by the recursive relation Fn right here. N subscript equals Fn minus 1 plus Fn minus 2. It starts with 0 and 1 and sometimes 1 and 1. Also, the Fibonacci sequence is found through nature in various patterns, including arranging leaves in a stem, a snail's shells, flowers' petals, and spirals. A practical example of it is the seeds, the arrangement of seeds of a sunflower. It is also found in the hexagonal scales of a pineapple, 5, 8, 13, 21. These form part of the Fibonacci sequence. Now, let us go to its uses. So, the Fibonacci sequence is used in nature, finance, and art. It describes the growth of plant populations and helps people arrange artistic and musical elements, to name a few. To expound on this further, the Fibonacci sequence is used for beautiful compositions, harmonious compositions in music, design, and art. In music, it makes rhythmic patterns for composers in order to determine the structure of the composition. The selection of musical notes also makes use of the Fibonacci sequence. It is helpful in mapping numbers to musical notes. It is also used in art to create visually pleasing paintings through application of proportion of shapes and flow of lines. It is also seen in paintings and sculptures. The Fibonacci sequence are also useful in data analysis, algorithms, and financial analysis, to name a relevant few. Let us now go to the golden ratio. It is 1.618033988875. It is a relationship between two numbers next to each other in the Fibonacci sequence. So as you can see, This is a Fibonacci spiral. It is a spiral drawn by connecting the opposite corners of squares. These sides are aligned with the Fibonacci sequence. This spiral visually represents the Fibonacci sequence, where each number is the sum of two preceding numbers. The golden ratio is often represented by the Greek letter phi, and its exact value is this. As you can see, this is the exact value of the golden ratio. Thank you for listening.